and welcome to our Steps of Data Analysis 6-week webinar class. I'm William Bannon of Stats Whisperer, and I will be bringing you the webinar presentation each week. First, I would like to say welcome. Thank you for taking the class. And first and foremost, we realize that you've taken the class with specific goals in mind, and we want to make sure those goals are met. It's nothing worse than taking a class with specific goals that you want to meet through the class, and then at the end of the class not having those goals met. So please make sure you ask as many questions as you like. Use the consultation hour. We just want to make sure that the reason you've taken this class is fulfilled. So the objective of our webinar, to break it down to the bare essentials. First, we're going to review the 7 steps necessary to conduct a data analysis study. And 2, we're going to make data analysis understandable and implementable and enjoyable. So enjoyable might not be a common word associated with data analysis, but you'll see in order to conduct effective data analysis, enjoyable is a big factor because there's a lot of small details and a lot of methods, and if you're enjoying them, I mean, you're better engaged, they sink in, and they're executed more swiftly, right? So enjoyable is a big factor. They would say, I would never go through this process except that I just love it so much, right? So that's kind of data analysis to a T. So if we could stimulate our curiosity and, you know, our curiosity to a point where we're willing to apply all these methods of data analysis, that's a great place to be. So the reasons most people take this webinar is 1, they need to conduct a data analysis study themselves, be it a research or a dissertation study. 2, they want to learn how to better interpret data analysis and quantitative research, be it peer-reviewed published papers or research reports, or even, say, 3, right, grading student papers, or looking for effective teaching methods for data analysis to make the process clearer and more meaningful for students. So we need to ask ourselves at this point, what's needed to meet these 3 needs? Do you need to have a super brain? Do you need to write information regarding data analysis on your hand for quick and constant reference? Do you need the A-team? No, you don't need any of these. All you need is an overview of the fundamental steps to follow to produce an effective and legitimate quantitative study. So when you think about it, the fundamental steps are a protocol. So every important process should have a protocol that lists the steps that should be followed toward effective and ethical practice. So we'll generalize surgery to data analysis. Okay, so the fundamental steps in surgery, we might say that there are 3 steps, very broadly. Right? So 1, there's the pre-op phase, pre-operation, before the operation. 2, there's the performing the operation, you know, the during part. And then 3, the post-op, after the operation. Now, in terms of methods, one of the methods is that the initial washing the hands of the surgeon happens in the pre-op, right? So before the operation, the surgeon is supposed to wash his or her hands. Now, it wouldn't be very good if the initial washing of the hands occurred in step 3, the pre-op phase, or post-op phase, pardon me, right? So we want to make sure not only we know what to do, but also when to do it, right? So when we consider the 7 steps of data analysis, that's what we have here. They're going to tell us what to do and when to do it. So a little personal note before we get started here. I myself was not a statistical prodigy by any stretch of the imagination. Even school itself had its share of woes early on. But what happened was, in undergrad, as a sophomore, I found this program where there's a will, there's an A. And in it, Dr. Claude Oley described that there's formulas for academic success. If you do A, B, and C, you know, your academic outcome is this, right? So I actually started applying that concept, and things got better. So, and then when I got into data analysis, right, I figured out that there's actually 7 steps. So when I had to do my own research, I broke it down into 7 steps. You know, I did my research, I got everything done, and then I started consulting with people. And what I noticed was I was teaching them the same 7 steps, you know, that I developed for myself. So these 7 steps aren't just something, you know, that I wrote down. This is like something I lived and I came up with to make my life functional, and then I helped make other people's lives functional. So I decided to, you know, put it in the book, in the webinar, to try to help as many people as possible. So here are our 7 steps of data analysis. And so it's really kind of intuitive if you know the materials, which you will very shortly. So the first step is study map. So step 1, study map. All we're doing is listing the relationships being studied. You know, but we're examining which variable, and we're examining which variables impact that variable. Right? Very simple. 2, data entry. So we want to take the data from the study surveys and enter it into the software. Make sure it's entered correctly. Then 3, checks of integrity, right? So we want to make sure the data are appropriate for analysis. That's really kind of, that you'll see that's sort of the biggest step, and it's also the most skipped over within the literature. 4, univariate analysis, where we're just describing our variables. And then 5, bivariate analysis, where we examine on a one-on-one basis how each variable impacts our variable of interest, our dependent variable. And these tests commonly are like t-tests, chi-squares. You may have heard these if you've taken a stats class before. And then 6, multivariate analysis, where we test the joint effect of many predictors on the dependent variable, and we use procedures such as regression. And then 7, the write-up and report, where we report the findings in table and text form, right, which is a process unto itself, independent of the other 6. So our webinar agenda. So in week 1, this week, we're going to go through the intro, go over the need-to-know concepts of data analysis, and then we're going to look at step 1, the study map. I know it just says data entry, but it's a lot more involved than that. There's data cleaning, there's all sorts of things. In week 3, we'll be reviewing step 3, the checks of data integrity. Week 4, we will go over steps 4 and 5, uni and bivariate analysis. And then week 5, we will be going over multivariate analysis in step 6. And then finally, week 6 will take us to step 7, the write-up and report. Now, the biggest danger to be avoided in when discussing, well, almost anything, but especially statistics, is presenting so much information that nothing is learned, right? Sort of overwhelming yourself or anybody else, right? So there are additional materials in the 7 Steps of Data Analysis textbook that we're not going to review in the presentations, but they're there as supporting materials. We want to keep the presentations to an hour or 2 hours, but if we reviewed every little thing in the book, it would be 5 hours and nobody would watch. I shouldn't say nobody, but chances are reduced, let's say. So upon completion, the attendee will be able to effectively communicate the fundamental steps of a quantitative research study, 2, structure and implement a quantitative study, and 3, assess the quality of quantitative studies. So one note I'd like to make about the Steps of Data Analysis model is that it's an overall model, right? So we're not just learning little parts, we're looking at the overall whole, right? So it's similar, right? So it's similar to being taught the symphony, right, which is a whole, not just individual instruments such as the tuba, which are a part of the symphony. Between learning music and statistics. So let's take music as an example. So suppose you enroll in a music program. You've never seen a symphony, right? So you've never seen the larger process of instruments working together. Now, your first class on your first day is about the tuba, and you might find the tuba confusing. You may say, what is this large horn? What's its meaning? What's its usefulness? Why do I have to learn about it? Why is it useful to me? Okay, so if you then see the tuba as a part of the overall symphony, then you may realize that you're learning individual parts of a greater whole. And once you learn enough parts, you're going to understand the whole. So this is how it's common to statistics. So if you enroll in a program, you've never seen statistics, or specifically, you've never seen the steps of data analysis, how the larger process of the statistical test working together, you also might have a similar experience. Say on your first day, you have your basic stats, and you learn your t-test, right? You may say, what exactly is this, right? Like the tuba. It may look awkward. It may look big. Say, what is this? How is it meaningful to me? How is it useful in general? Right? However, if you know the 7 steps of data analysis, you might say, oh, the t-test is a part of step 5, right? So it's a part of a greater whole, again. So once you learn enough parts, you're going to understand the whole. So we're also going to review today the need-to-know concepts of data analysis. So some of these are complex and intricate, and some of them are basic, but all of them really need to be known in order to have a solid understanding of statistics, and also the terms commonly used, associated with the process. So instead, you can see there are 9. So instead of listing 9, now let's just go through them. So first, statistics are often broken up into 2 categories, being parametric versus non-parametric statistics. So the parametric, these are the more widely used. Right? They're the tests that make assumptions about the data. Perhaps the most commonly known is a normal distribution, right? So many tests assume that scores are normally distributed, and then you do tests such as the t-test, the correlation, the ANOVA, which we'll do in this program, right, that make these assumptions. Now, non-parametric statistics are tests that examine, typically through rank order, the relationship between variables without making as many assumptions. And for our purposes, perhaps the most useful part of non-parametric statistics is that when your data do not meet the assumptions of the parametric statistics, right? So if you have a distribution that's not normal, a non-normally distributed variable, you could consider using the non-parametric equivalent of the test, you know, as a solution. So we'll go through that in more detail later on. Also, statistics are often categorized as descriptive versus inferential. Now, your descriptive statistics, also called univariate in our program, are statistics that describe a characteristic of a sample or a population. So basically, you're describing each variable by itself, right? So if the variable is happiness, you know, what's the highest score, what's the lowest score, what's the average score? So it's just that one variable by itself. Then inferential statistics, as you can see, the word infer is in inferential, right? So that's our goal. We're using these tests to make predictions or inferences about a population based on the observations made through the sample. So basically what that means is the results of our sample, right, the study results of our sample, we're trying to infer, right, things about the larger population. And so if we have a sample of students, right, so and we do a study, then we want to infer those results upon the entire sample, the entire population of students, right? So inferential statistics. The statistics that say what is associated with what else. So levels of measurement. So generally 4 levels, and it's important to realize in statistics, important decisions such as which tests are used are often based upon the level of measurement of certain variables. So the 4 general levels, nominal, ordinal, interval, and ratio. So nominal, it's a categorical variable, right? So it puts things in categories, but they can't be ranked, right? So there's no reason to think, you know, one belongs higher or lower than the other. For example, race or gender, right? So if you have male or female, you really can't rank one above the other. They're just equal categories. Now, number 2, ordinal, that's categorical, but the categories can be ranked, right? So we could say poor, fair, good, excellent. There's a little crescendo there, right? So from poor to excellent, you have a rank, right? But there's no reason to believe that there's an equal distance between categories. For example, there's no reason to believe that there's an equal distance between poor and fair versus good and excellent. It's largely conceptual. Then we have our dichotomous variable. So this is a special case where we have a categorical variable with just 2 categories, right? And it's a very common term used, so I'm making a little note of it right here. Then we have our interval and ratio variables. Interval, meaning it's measured along a continuum with equal distances between measurement points, right? So, for example, the IQ test, a score like 10 points from 90 to 100 is the same 10 points from 100 to 110, unlike the fair, good, good, excellent example, right? So equal distance between measurement points, but there is no meaningful true zero. Right? So, for example, an IQ test measures general intelligence, but a score of 0 does not mean a complete lack of general intelligence. Now, 4, ratio, is almost the same, except there is a meaningful true zero. Right? So a good example of that is measuring weight. Right? So a weight of 0 does indicate a complete absence of weight. Now, in the real-world application, we often refer to variables as either categorical, which is nominal or ordinal level, or continuous, which is interval or ratio level. Right? So that's how we will refer to them in this program, as either categorical or continuous and dichotomous. Is a single versus composite item score. So some variables are measured with one item, a single item score. For example, here we have the variable education, right? So that could be measured with a single item, such as what's your highest education level completed, and the respondent would choose between A, high school, B, college, C, graduate school. Right? So that's one item measuring one variable. Versus the composite item score, which are many items that usually each item looks at one dimension of the variable measured, right? So if we're measuring happiness, we might have 3 items, each one of which measures an aspect of happiness. Then the items are combined into one single score. Right? So 1, the respondent could say, I feel happy on a scale of 1 to 3. 2, I feel glad. 3, I feel good, right? And normally these items would be combined, perhaps through taking the mean score, through summing them and dividing by the number of items 3. Right? And that single mean score would be the value, the composite value, reflecting happiness. So that's our composite score. Then study variable type. So our independent variable, also referred to as the predictor variable, is the variable of interest. That explains the dependent variable. Right? The dependent variable, also called the outcome variable, is our variable being explained. Right? So for example, in our sample studies, the dependent variable, and the first one is happiness, and the independent variable is, do you live with a dog or a cat? So we want to know if living with a dog or a cat explains happiness. Then the next type are the covariate variables, also called predictor or control variables. That are the variables in the data set that may not be the focus of the study, but they have some significant impact on the dependent variable or independent variable. So we want to include those in the analysis to control for their effect. And so it's important to note we're kind of going through these points, relatively quickly because we just want to touch on them, but we'll be going in depth on each of them and not only explaining them, but applying them. So that'll be a lot more beneficial to our learning. But right now, like I said, we're just touching upon them. So 1, the clarity of the study hypothesis. right? So I have a few points to make about this. One, present one relationship at a time, right? So consider the following hypothesis. People living with dogs are happier, healthier, and more optimistic than people living with cats. Now, if you think about it, this is really three hypotheses. We always want to be able to say if a hypothesis was supported or not supported by the data. But if we have three rolled into one, we can't say that because some might be supported and some might not be. So if we really break these down, we could see the three hypotheses. The first one, people living with dogs are happier than people living with cats. People living with dogs are healthier than people living with cats. People living with dogs are more optimistic, right? So through this way, you could say if each one is supported or not supported, right? So that first sentence was really three hypotheses in one, which is not what we want, right? So make the cause and effect relationship clear. You could consider using the if-then format, right? If a person lives with a dog, then he or she will have a higher level of happiness relative to a person that lives with a cat, right? So you don't need this format, but having the cause and effect relationship established is very important. And third, just make sure it's there's a level of specificity of the variables being examined, right? So a vague hypothesis might be the type of pet owned will be significantly related to levels of happiness. Right? We don't know what kind of pet. We don't know, if they'll be more or less happy with which pets, right? So a specific statement might be people who live with a dog have a higher level of happiness relative to people that live with a cat, right? So more specific is better. Okay, now, the three dimensions of a variable relationship. This is actually something you don't see much. These three dimensions listed like as a cluster like this, but this is very, very important, right? So to examine the relationship between study variables, you need to consider three dimensions. One, significance. Two, directionality. And three, magnitude. So again, whenever we look at the relationship between variables, we want to know significance, directionality, and magnitude. So the first one, significance, or as we call it, statistical significance, is a level of probability that reflects how likely the relationship is a result of chance. And the common standard is 5 times out of 100. And then less than symbol, less than 0.05. So it's considered statistically significant if the p, which is the p-value, is less than 0.05. So categorically, if the p is greater than 0.05, it's not a statistically significant relationship, versus the p is less than 0.05, then it is. So this begs the question, what does by chance mean, right? So if we're saying that 5 out of 100 findings are by chance, what does that mean? So by chance really means that there appears to be a significant relationship, but in reality, there is not. So in statistics, 0.05 reflects that we're willing to accept that 5 out of 100 findings we call significant are not, but they are by chance. So what does that mean, right? So we have in the text our example. So a man is asked to hold a slice of pizza by a client signing forms. Right? So the man's coworker comes by and sees him holding the pizza and assumes he likes pizza, right, because he sees him holding a slice. So the man says, I don't like pizza. You just happen to see me holding this slice by chance. Right? So you can see even in our vernacular, we actually use this term by chance, as to reflect sort of like a fluke or a coincidence, right? Just happened by chance, right? It's the same thing in statistics. So the relationship appears significant, like it appeared like the man likes pizza, right? There's a significant relationship, but in reality, there was only the appearance of significance. So in statistics, what we're saying is that 5 out of 100 tests, right, that it's going to look like a significant relationship in that the software is going to say P is less than 0.05, right? So it's going to look like there's a significant relationship, but that's going to be false, right? Just like the man with the pizza, right? So in other words, the way the pizza faked us out to think there was a significant relationship, every so often, 5 out of 100 times, the software is going to fake us out and give us a significant finding, P less than 0.05, when that finding really doesn't exist. So that's all that the by chance really means. So directionality. So directionality is either positive or negative with the relationship, right? So a positive relationship is when there's two variables, as one increases, the second increases at a significant level. So a positive relationship between income and happiness would indicate as income increases, happiness increases. So that's a positive relationship. So the directionality is positive. As one goes up, the other goes up. The negative relationship, as you might surmise, is when there's two variables, as one increases, the other decreases. So a negative relationship between income and happiness means as income increases, happiness decreases. So they're indicated in statistics with a minus sign or the lack thereof, right? So a negative relationship is indicated by the presence of a minus sign in front of the statistical coefficient. A positive relationship does not have a minus sign. So, for example, if we look at the Pearson R coefficient, which is a correlation coefficient, right? If R equals negative 0.35, there's a negative relationship. But if there is not a minus sign, where R equals 0.35, then that indicates a positive relationship. So, as I said, we'll be going through this many, many times. So to sum it up, minus sign, presence of a minus sign, there's a negative relationship. No minus sign, a positive relationship. Now, magnitude. The magnitude is something we really have to advocate for because it's underplayed in the literature, but it's super important. So magnitude reflects the strength of the relationship between study variables, which means how impactful is one variable upon another. So the magnitude of a relationship can be indicated in several ways, including the effect size, which we'll consider here. Right? So there are other ways, but a very common way and preferred way is to look at the effect size of a relationship. So it's very important to note that a relationship could be statistically significant, but have such a small effect size that the relationship is inconsequential. So the effect size is a huge consideration, and it's often passed over. So often in the literature, we see variable relationships categorized as significant or not significant, and that's the extent of it. However, a variable can be significant with a huge effect, or significant, like I said, with an effect size so small that it basically doesn't really, it's not really significant to our study. For example, we might look at happiness, and we might speculate that there are factors that are very impactful on your happiness, such as income level, and factors that are less impactful, such as the weather or having a bad hair day. I guess those two might actually go together sometimes. So let's suppose that we did an analysis and we found that all three, income, weather, and having a bad hair day, were all significantly related to happiness. Right? So it might look like this. Right? So on the left, we have our predictors of happiness. On the right, we have happiness. Then in the middle, we also have our effect sizes. So we're saying that all three factors are significantly related to happiness, and that's where a lot of research leaves off. However, we could see that income level has a large effect on happiness, weather has a medium effect, and having a bad hair day has a small effect size on happiness. So you could see when you only look at the significance, you're leaving out a great part of the story, right? Because like having a bad hair day, might be significantly related to happiness, but relative to your income level, having a bad hair day might not even matter. But if you leave the analysis at only significance, that's passed over. So that huge part of the story is just passed right over. As an illustration of the effect size, you might consider, right, this is in the text too, you want to predict how much you enjoy your meal, right? So if you have your appetizer, entree, and dessert, if the appetizer is the least important part of your meal to you, it might have a small effect on how much you enjoy your dining experience. If the entree is the most important factor to you, it might have a large effect, right, on your dining, how much you enjoy your dining experience. And the dessert, if it's moderately important, might be right in the middle. So all of them might be significant in explaining how much you enjoy your dining experience, but in terms of effect, one might be so much more powerful than the other, it might make the others not matter at all. Like I said, that's a big part of the story. So magnitude, right? So an indicator of magnitude could be described as a small effect size, a medium effect size, or a large effect size. So we have our three dimensions of a relationship. So in any relationship, always SDM, right? Savor daily miracles. And so S being significant, D being directionality, and M being magnitude. So we always want to look at those three factors. All right, our next need-to-know concept is the Russian doll effect of data analysis. So Russian dolls are figures where, except for the last, each doll goes into another doll, right? So each doll contains smaller dolls, essentially. And this relates to statistics because in data analysis, each procedure incorporates a series of smaller procedures. So you can see on the left, right, so we have the left, we have our overall construct, right, our big 7-step model. Then if we look at step 3, checks of data integrity, and then we look at the second doll to the right, we see that step 3 breaks down into 4 checks. So initially we have our 7 steps. Then we take one of those steps, step 3, and that breaks down into 4 checks, right? So if we look at the number 2, the test assumptions, right, we see that that breaks down into many assumptions, right? One of them being the first one, normality. Then if we consider normality, that breaks down into further things that need to be examined, the last little guy there, skewness, kurtosis, and outliers, right? So that's the point, that within each function, there are smaller little methods and procedures that need to be considered. And our final need to know, right, haste or paste, save the syntax, right? So when conducting a statistical test in SPSS, you'll see each time you have the choice of clicking OK, and the test is run automatically, or clicking paste, where the syntax is produced, and you can save it in a syntax file, right? Once the file is produced, you just highlight the syntax and click the Run button, and you get the results the same as if you clicked OK. But you can save the syntax. So although it's more expedient to click OK, the action is often made in haste. So clicking paste and saving the syntax is useful on many levels, such as having an electronic paper trail. You could see what you did, and more importantly, perhaps you could see if you made any mistakes in what you did, right? Because if you click OK and you made a mistake, you can't see what you did because it's just implemented and there's no trail, right? Also, if you need to repeat the procedures, you could just highlight them and run them whenever you need, rather than structuring them over and over again. So we would advocate for clicking paste over haste. So lastly today, we're going to be applying the 7 steps to sample studies 1 and 2 in the form of our study maps. All right, so sample study 1 is a quantitative study with a continuous dependent variable. And as the title suggests, right, so we're going to apply the 7 steps to data analysis to illustrate how to conduct a quantitative study with a dependent variable measured as a continuous variable, which is, at the interval or ratio level. The research question, are people who live with dogs happier than people who live with cats? And the hypothesis is that people who live with dogs are happier than people who live with cats. So the study map is a stage of analysis where the study variables and hypothesized variable relationships are listed in text and diagram form. This is great for clarity and organization, especially when you get into the analysis and you're doing all these different procedures. Sometimes you forget what you were originally looking at, so it's great to have it written down. So you can see when we present the study map in text, we have the research question, the hypothesis, the dependent variable, happiness, the independent variable, do you live with a dog or a cat, and we've also listed our covariate variables, education level and income level. Right? So it's just a comprehensive statement of the variables we're examining. This being in text, and the diagram is perhaps even more useful. The whole "a picture is worth 1,000 words" applies here. So you can see on the left, we have all our predictors, our 2 covariate variables, education level and income level. We've noted, that they're categorical. The first one's categorical, the education level, and it goes from high school to terminal degree. Covariate variable 2, income level, is continuous, and it goes from 0 to the highest number. And then lastly, the independent variable, do you live with a dog or a cat, is a categorical variable. And the dependent variable, happiness, is continuous. And then sample study 2, you might ask, why 2 sample studies? Because the procedures are different when you have a continuous dependent variable rather than a categorical dependent variable. So in sample study 2, we have a categorical dependent variable to illustrate, how to do that analysis, as well as draw distinctions upon the difference between the 2 studies. So we're looking at how to apply the 7 steps to conduct this quantitative study with a dependent variable measured as a dichotomous variable, which is a nominal or ordinal level variable with 2 categories. So we could see the research questions just changed a little. So are people who live with dogs more likely, right, so more likely to be happy relative to people who live with cats? And the hypothesis is, again, that people that live with dogs are more likely to be happy relative to people that live with cats. Same deal when we write it in text. We have our research question hypothesis, the dependent variable, happy, yes or no, and the independent variable, do you live with a dog or a cat, and the covariate variables again. And we also have it in diagram form. Right, same thing, except the dependent variable is now happy, yes or no. Right? Now next week, we will be looking at data entry. Right? Are the data entered right? Are they cleaned properly? All these sort of great things. So thank you for attending our first class on the steps of data analysis. Thank you for watching. Be sure to email any questions for clarity. And have a great week. Okay, goodbye.